Here we go. So we're going to be graphing radicals. All right. We're going to be graphing radical equations. The nice thing is we're going to be graphing shifted radical equations, which we already know how to do all this stuff. This lesson took me 20 minutes last hour. So let's focus and go through it here. So we know how shifting works. Shifting works the same for all shifted functions. So we're going to be graphing shifted square roots and cube roots. Now everybody look, here is what a shifted square root function looks like. It'll have this format. So if it looks like this, you can determine the shift from the parent function. So everybody, shifting for all functions works the same. This is my shift left and right. We go opposite. We already know this. This is my shift up and down. Your sign will stay the same. And then this A in front is called the acceleration. It's not a slope because it's not a constant change, but it's an acceleration. And it's stretching it out, a vertical stretch if it's larger than 1, and a vertical compression if it's less than 1, because the acceleration is getting larger, slower, so it's compressed down. Then remember, the two other shifts are, if there's a negative in front, it's technically its own shift. This negative in front with A, the negative is a reflection over the x-axis. And then this negative in here in the front with x is a reflection over the y. Now, how it was really easy for me to remember that is literally, it's so funny. This morning, I was like laying in bed thinking I gotta get up, and I was thinking about this lesson, and it like, I don't know what it was, but today I was like, oh yeah, reflection over y, and then I was like, oh yeah, that makes sense. I already knew it, but I just didn't think about it very good. Think about it, guys. If I take and plug in 3, think about why this is a reflection over y. If I plug in positive 3, now won't it be negative 3? Everybody? Wouldn't that take me over here across the y-axis, everybody? So it was like I was laying in bed this morning and that like dawned on me. I'm like, I knew that, but it just all dawned on me this morning. I don't know why. So that's kind of easy to remember. And then I started thinking about this. So if I have some value for y, and then I have a negative 1 times to it, that would take it down here. That would be a reflection over x, right? Think about a point. If I have 3, up 3, and I times it by negative 1, what's going to happen? Now, do you see how that reflected it over x? So it kind of was easy for me to remember. Okay, so this is really the easiest way to do this is to look at the parent function and then determine the shift from there. So let's just look at the square root parent function. First of all, what's my domain? Greater than or equal to 0. So if I started at negative 1, that would be I not happening. Where can I start at? 0. So I plug in 0, get out 0. What's another one that comes out to be a whole number? 1, square root of 1 is? Square root of 2 is a decimal, so I'm not going to put that point. Yep, good. 4 would be my next one, so that's a 2. Let's do another one. 9 is the next one, though, right? And then 16 is 4. So look, let's graph that. You could even just watch me. Over 0, 0, over 1, up 1. Over 4, up 2. Over 9, up 3. So it looks like this. It looks like it makes total sense, guys. We learned how to look at domains just looking at it and thinking about the algebra. Well, it all really will work out in the graph. So look, our domain is from 0 to infinity, correct? We already have stated that based on the equation. Now, what's my range? Y is, yep, 0 to infinity. Or y values are greater than or equal to 0, like you guys were saying. Good. So now all we're going to do, you guys, is we're going to take those points and we're going to shift them. Shift from the parent function. So if I said right 3, that would take all these points and shift them right 3. Does everybody see? So it looked like that, right? If I said I'm going to put a negative 1 in front of root x, that would take and reflect it over the x-axis. So that point would come down here. This point would come down here. This point, you guys get the picture here. Sweet. Hey, here we go. Determine the shift from the parent function in words. Let's state it in words. right 3, up 2. Now, really, the easiest way to do this is not, I don't want to have to plot the parent function every time and then move my points. That is one way to do it. But instead, remember when we did this a couple units ago, given the parent function's xy points, let's change them by doing these shifts and then plot the new points? That's what we're really going to want to see. So here are my parent function points. I got those from square root of x, parent function. We're now shifting them right 3. Isn't that an x shift? So we're going to add 3 to all of our x's, and then we're going up 2. So add 2. Let's write out our new points. 3, 4. Okay? Okay, let's plot those. Over 3 up 2, over 4 up 3, over 7 up 4. And do you see how that would connect? Yeah, something's off here, huh? Yeah. So we're still good. Yeah. We're still good here. But then do you see how that's enough points? I can't fit 12, 5, so that's good enough. Now, once again, look, we know that it started at 0, 0, shifted right 3 up 2. So there's my starting point, and here I am. Everybody good? Pretty easy stuff. So then you say the domain is 3 to, including 3 to infinity. What's my range? 2 to infinity. Very good. Because it was shifted right 3, taking us from 3 to infinity, and up 2 would be from 2 to infinity. Okay, let's do another one. Here we go. In words, left 1, down 3, and then a stretch of 2. Yep, reflection. I'm just going to point over x. Okay, so now here's my parent function's points. So now think about it, guys. Isn't this a vertical stretch? So we're going to take -2 and multiply it to your y values. So that would be our vertical. You have to do multiplication before addition. Think of order of operations. So we'll take our y values, we'll times them by -2. Then are we going to take our x's, subtract 1? After we times by -2, we'll then subtract 3. Does everybody see why? So I would then write out my new xy points if need be. But once again, my starting point's really easy. I'm going to go like this. Left 1, down 3. Does everybody agree? Okay, so let's write out our new xy points. Everybody just, it's hard for me to look up here because it's so big. You tell me on this side. -1. 0. 3. Okay. That's a time sign. So this one's -3. 0 times -2 is 0. 0 minus 3, -3. Okay, so I can plot those points. I already have -1, -3. Now I'm going over 0, down 5. Then I'm going over 3, down 7. Can I fit another one? Over 8, down 9. All right, down here, right? So look, makes sense. Because it was reflected over x, wasn't it? So it looks good to me. So now we would say, okay, our domain is -1 to infinity. Does everybody agree? What's my range? Isn't it going down to -infinity? So then just don't forget, we do write that first, smallest to largest. So it's coming in from -infinity and it's up to -3. Right. Correct. Okay, good. I think you guys probably get the picture here, right? You get the picture? Do you need another one? Maybe one more with this interesting reflection? Okay, so here we go. We would say, okay, careful. This one tricks people. What is my true shift here? Okay, so you're right, reflection over the y. So I'm just going to write r over y. So don't I factor out a -1? Left is x plus 3. So it's actually left 3, everybody. Okay, so now we have to be really careful. Here's my parent function points. If this is reflecting over y, doesn't that need to change my x values to be opposite? So you would take your x values, you're going to times them by -1, and then after that, are we going to subtract 3 off of them? Okay, here we go. You guys tell me. Okay? Okay? Oh, sorry, I was kind of covering it up with my arm. That's okay. And what was it here? Okay, what are my y points, everybody? 0. The y's didn't change, right? So that's why he's so quickly saying 0, 1, 2, 3. I just can't tell because no one's saying anything besides Tanner. Thank you, Tanner. Oh, Eric says thank you. I'm sorry. Your voices sound the same. No, they don't know. Okay, so let's do this. First of all, so I like to just graph my start, well, -3 up 0, right? -4 up 1, -7 up 2. Well, that makes sense. Okay, good. Our domain is -infinity up to -3, and my range? Uh-oh, not quite. You're okay. 0, that's actually a common mistake, so 0 to infinity. That's okay. Okay, I want you to do those problems on the worksheet now. So just do a rough sketch. If you make your own tick marks, meaning all I care about is if, let's say you shifted right 3 up 2, go like this. Like this for me, 3, 2. Then I know you knew where it was. Okay? Okay, next thing it says, solve the radical equation. I want us to do it by hand, and then we'll verify our answer by calculator. Because we already know how to do it by hand. Solve for x. So what should I do here? Square both sides. So then we'd have x minus 2 equals 1. So x equals 3. Then we take the liberty of checking it. Root 3 minus 2. You guys have to check them, guys. You have to. So we have the square root of 1 equals 1. 1 equals 1. Yes. Okay, now we're going to solve by calculator. So what's going to happen, guys, is think about what this is literally saying. When does this function equal this function, correct? So go to y equals in your calculator. Everybody do it. In y1, type this in y2, type this in, and graph them.
Whoa.
So we would have a straight line up at 1, and then we have our square root function, and they intersect at x equals, you do second trace intersect, we already know, right? 3. Do second trace, intersect, go through the motions, make sure you can get that so you can check your answers. It intersects at x equals 3. Did you get that? Okay, cool. Now let's do this one the same way, but let's do it by hand first. Square both sides, won't we? So then we have x plus 3 equals -x plus 3. So add x over, subtract that. So we would have 2x equals 0, so x equals 0. Now let's check it. Does the square root of 0 plus 3 equal the square root of -0 plus 3? Does root 3 equal root 3? Yep. Graph it. Do they intersect at x equals 0?
Yep.
Yes, it's so neat. Boom, there's the intersection, so that's when they're equal. Yeah, okay, let's do this one by hand. Square both sides. sides, won't we? Square root, oh, not square root anymore. So we would have x plus 3 equals x minus 2. Then don't we subtract x? So 3 equals negative 2. Wait, is he joking or just kidding? I don't know how to answer that. What a jokester. That's not true. Well, what does that mean? Now graph it, and you'll notice they never intersect. So that's no solution. Cool, right? Okay, so do that next section there. Cube root functions. Now, I'm going to ask you a question. I want you to think for like 30 seconds before you answer. What is the domain of cube? Don't say it yet. What is the domain of the cube root of x? Think, don't say it. I'm asking you, what are the possible x values? What's the domain of the cube root of x? Do you agree, Josh? Yeah. Okay, so it's all real numbers. Now think about why. Can't I plug in negative numbers into cube roots? Yeah. So with the parent function, the non-shifted function here, let's plot pretty points. What's a pretty point? 1. -8? Let's go in order. And then negative, well, we gotta have more than 1 point. So -8, -1, 0, 1, 8. So I picked those because then they come out to be whole numbers. Cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So let's draw our graph in here. So look, a cube root looks like this, kind of like a snaky looking thing. So if you look at it, the domain really is all real numbers, or negative infinity to infinity. Because there's no problems when plugging in our domain. What's the range going to be? Yep, all real numbers are negative infinity to infinity. Isn't it growing, even though it's growing slowly? So negative infinity to infinity. So now think about it, you guys. We can treat this just like all other shifted functions. Take your parent function and then shift those points. So look at this one. We would say left 3, left 1, down 3. So you would just treat it the same way. So left 1, subtract 1, and then down 3, subtract 3, and you'd plot your new points. Okay, if you guys get the picture, we're not going to do it. Do you want me to continue or not continue? Okay, it's a snake, so you would just treat it the same way and then plot your points, correct. Now everybody think about it. If I take this cubic and I shift it over here, not drawing it in perfectly, what would my domain still be? Same thing. What would my range still be? Still the same. So shifted cubics will still have the same domain and range. Okay, I think you guys get the picture unless you want me to do more, but I don't really know if you do. So this negative, though, right, would take, now look, I'm just going to go back. If we put a negative in front, wouldn't that take this point down here? This point up here reflecting over x. So wouldn't that point come down here? And then this, yeah, it kind of does look like that. So it would look like this. Does everybody agree? A backward snake. That would be a reflection over x. Didn't I just take all my points and reflect them over x? This point is right there on itself. 0 over 0, right? Okay. Now what if I took and reflected over the x-axis and then over the y-axis? What would my graph look like? It'd become the red function again, wouldn't it? If I reflect them down here and then put that point over here, does everybody see? Okay. All right, so I guess we don't need to go through it then. It sounds like you guys have got it good to go. So grab those cubic ones then, and do domain and range on them. You guys, I just want you to look back up here. So I just finished off graphing that one just so you guys could see. If you ever have like a hard time of being like, what should my function look like? Just go back to what does the parent function look like, and it should kind of look like that. You know what I mean? So that kind of helps. Okay, continue. I'm just going to keep going for my video up here. Keep working. Yeah.
Oh my goodness, I would have died. Okay. And then if I had to like, if I died, it's Friday. Oh, I'd be so sad.
I bet we'll be able to get to it if you'll just focus on this last little piece. Okay, here we go. So it says, determine the shift from the parent function. Couple things to note. You can't determine the true shift unless this is just like 1, okay? So everybody, there's a problem right there. We've got to fix all this. But we've got to keep our math nice and sound here, like our algebra. So we have 3. I'm going to factor out a 4. Now, I don't mean factor it out. It can't magically flow out of the root. It's still under the root. But I'm going to pull it out of that term and that term. So I have the square root of 4 times x minus 1. And then don't I have my plus 1 out here? Yep, so now because this is multiplication, it would be appropriate to say we have the square root of 4 times the square root of x minus 1. Because we know if they were separated like this, we could put them together. So that means we can break them apart. So isn't that 3 times 2? 6 square roots of x minus 1 plus 1. So let's describe our shift. Right 1, up 1, stretch of 6. Now without graphing it, we could graph it now obviously, but without graphing it, what's our domain? See, Adam, you're smart. Okay, what's our range? One to infinity. You guys, it should be so straightforward. Why are we taking such a long pause between? It shifted right 1. 1 to infinity. And then remember, we could even look at it algebraically. X values are greater than or equal to 1. Right. Now just think about how shifting works. Now, didn't it used to be at 0, 0? We now shifted it up 1. So that would be 1 to infinity. Like we shouldn't be making this harder than that. Okay, let's look at another one. So this is, let's see, negative. The square root, we'll pull out a 16. Left is x minus 2. So isn't that negative? The square root of 16, square root of x minus 2, which is negative 4 square roots of x minus 2. Right 2, stretch of 4, reflection over x. Now careful, if you needed to draw yourself a rough sketch to think about it, right 2, reflection, whatever, like this, correct? I didn't draw that. I didn't mean to do that. There. Like that. So our domain is not negative 2. 2 to infinity. Was there any shift up and down? Okay. Is it 0 to infinity? It's going downward since we reflected it. Yep, negative infinity up to 0. Okay, let's do a couple cube root ones. Notice something interesting happens here. People always get thrown off by this for some reason. Shouldn't I just say this is positive 3? So plus 3 out here, not a time sign. So then we have the cube root. I'm going to pull out a, yep, negative cube root. What am I going to pull out here? Nope, that would not fix that. Pull out an 8. Then divide by 8, divide by 8. We got to pull out 8, guys. It's got to be 1. So then left is x minus a half plus 3. So negative cube root of 8 times cube root of x minus 1/2 plus 3. So negative 2 cube roots of x minus a half plus 3. You say right 1/2, up 3, stretch of 2, reflection over x. Domain for cubes. Cubic. Cube roots, I meant. And range. Good. All right, so I think, okay, watch. This one's interesting, okay? So one more example. Right here, we have a negative 2. We're going to factor out a negative 27, aren't I? Then left would be x minus 3. What's the cube root of negative 27? Negative 2 times negative 3. So we have 6 cube roots. So isn't it positive 6? Cube roots of x minus 3. So we'd say right 3. Compression. No, stretch of 6. Now watch. Think about why that makes sense. If we reflect it, remember how we said if you take a point and reflect it over the x-axis, right? And then reflect it over the y, that would be the original cube root, wouldn't it? So it cancels out, making it positive. Okay, cool. Our domain and range, all real numbers. Okay, you guys are doing great. That is the end of the lesson. So I'm going to turn on Thunder Vision at this point. But I need you to finish some of those, more of those. Like we can either not do Thunder Vision and do 10 minutes of working, or you can do some at home and we can watch Thunder Vision, or you can try to multitask.